Okay, so good afternoon, everyone. Once again, welcome to today's training session. We'll be discussing Siemens PLC hardware configuration. I've titled this one Part 1 because I expect that we would have quite a lot of parts to this training session. So without wasting much of our time, I'll go to our GitHub page where I've updated some files onto this training folder. If you go to hardware configuration, which is 4, you would find some documentations that I've uploaded there. One of it is the Siemens hardware configuration. Basically, this is not complete. It's a very old documentation, but it explains some basic things that I want to highlight as well, which is, if you remember from the last training, I discussed about the PLC hardware where I mentioned power supply, CPU, input and output, or whatever other type of modules. This image here gives you a very good overview. For example, if this is a PLC rack and this is the software rack, you understand? Here in the position 0, which is here shown as 1 to 8, like I mentioned, this is quite very old. So this is position 0, the power supply, and you can see it says power supply 307. You cannot see this completely, but it shows 10 amps. And on this second position, you have the CPU itself, in this case, CPU 314. On the third position, you have an IM, which is somewhat like an expansion module. And then you have your digital input, analog input, digital output cards. Basically, this is how it translates from the physical PLC rack to the software rack inside the software. You can go through this documentation, not like you have to read it completely, but just to give you an overview. We also discussed the SCADA local control, and this image here also gives a very good overview. For example, let us look at this last image in this document. You see here, these are PLCs. You might not be able to see it completely, but these are PLCs, 1, 2, 3, and they are controlling some other processes. Now, these PLCs are also connected together, and there is like a PC here, which is used to monitor these PLCs. And then after that, these PLCs are connected to some servers here, which is what I explained you saying some IT network, things like that. And then they are connected to another PC, which you use to monitor. So on this level, you can see you can use this PC to monitor this 1, 2, 3 PLCs. It even connects up to another system here and then another system here. But you can see that this is one system, this is another system, this is another system. All the systems are then connected to this, which is usually like the SCADA, which monitors maybe this is plant A, plant B, plant C, or different processes. So you can look at this image to understand some things. Here, there is also an image here which explains how the PLC functions. I will come back to this image later to explain better. Then if you go into the documentation, I've added some links. The first link here is a video by a guy called Egamo on YouTube. You can watch this video. I highly recommend it after the session or whenever you're free, to also get another perspective as to how you can configure PLC hardware. We will go through that today, but you can also look at this video later just to give you different perspectives. For example, maybe something that I miss, you get it there. Or maybe if you have a question, maybe you find the answer there. Just to give you another perspective. Now, going into PLC hardware itself, how do you start? Normally, as a control engineer, you don't just start by opening your software and just configuring whatever you like. No, it doesn't start like that. It starts with a process. So a process, maybe there is something to control. And if there is something to control, there should have been a design. You understand? So either the design is being done by you yourself or someone else has designed the system, but there should be a design. So you look into the design to understand, okay, what do I need to program? What kind of process would it be? Here I have linked some two documents. I'll open that now. Um, Let me close this to be sure I'm opening the right ones. So here it says how to read PLC wiring diagrams for industrial automation. Usually, like I mentioned earlier, when you want to start a programming, when you want to start a process, you have a diagram that you need to follow because that's like the single point of truth for everyone. You, the designer, you, the PLC programmer, the control engineer, the guy who is wiring the panel itself, the control panel, um, the person who will do wiring on site, installation of the devices on site, everybody refers to the wiring diagram. So when you, as a software engineer, as a PLC engineer, picks up a wiring diagram, then what are the things you need to look out for? First, you should be able to understand what you're looking at. Reading wiring diagrams, understanding wiring diagrams is a complete separate topic or a complete separate skill on its own, which you need to learn. Yes. So I would advise that you start looking out for some wiring diagrams, documentation. I can also explain that in a different training session. But basically, you need to understand wiring diagrams. So there are two things. First, either the control panel that you want to program is already wired like this, and there's a wiring diagram that is inside this panel, and it comes to you as a control engineer. That's one step. You look at the panel, you look at the wiring diagram to understand what you're looking at. In many cases, you might find the PLC directly and its peripheral devices directly inside the panel. You would see the order code of the PLC, which you can then use in the software. In many cases, maybe the panel is not with you yet because probably somebody is still wiring the panel, but you get the wiring diagram as well. So while they're wiring the panel, you as a programmer can already start your programming on the side with the wiring diagram. So when you get a wiring diagram, you see things like this, symbols and images like this. If you're used to AutoCAD or ePlan, maybe you start having some idea. If you don't, this is also why I linked this page here. So if you read through it, you will understand some things. But let me go directly into what I want to show you. So you will always find a page similar to this. It doesn't mean it will be completely exactly like this, but it will be similar to this. And as I mentioned, whatever the PLC is, Mitsubishi, Siemens, Allen Bradley, whatever, they would be similar because you will see the same text, the same terms, the same terminologies would be what you would see in the wiring diagram. And they will tell you what kind of PLC it is. You would see the code. In this case here, on the left-hand side, you see a CPU. I explained to you earlier, you can have a power supply or not. If you have a complete 24-volt wiring coming from somewhere else, then you don't need the power supply beside the CPU. In this case, the power supply does not exist, which means there is a power supply connection coming from somewhere else. So probably in the control panel, there is a 24-volt power supply module sitting somewhere, which is sending 24-volt power to all devices in the control panel that needs 24 volts. So this is the CPU. These are some modules sitting beside the CPU. So I'll go to the page that shows it's completely in a clear way. Let me see. I think this one does. Yes. So I also linked this. You can watch this video. You can read all of this. You should actually. So if we go to the PLC page, something like this, you will find something like this. Why am I not able to zoom this? Okay, I'm not able to zoom it. Okay. So basically, it says this is the control 24-volt supply line. On the 24-volt supply line, there is a connection that goes straight to the PLC. This is a PLC. It says Siemens. You might not be able to see it well now. Probably you can. 3152DP. It gives the name of the PLC here, the type S7300, and then it tells you the model number. This is the model. It then shows you the different peripherals that are beside it, either input or output systems, whatever, but it gives you the code. So as a PLC programmer, you already have the page which you can start with. It means when you go into your software, you can already start building this hardware because this is the hardware that will eventually be in the control panel. So if we want to start with this, then we go to our TIA portal. By now, I expect that everybody has installed that. So if you open your TIA portal, you should start with somewhat of this page. Now, we will be using version 20 TIA portal professional. You all have downloaded this, currently using the trial version. This is my first time of using the version 20. Like I've told you before, the last time I used TIA portal was version 16. So we both would have some learning curves here. I don't expect a lot of differences, but I just need to tell you that. So basically, this is the first page that you see when you open your TIA portal. You can do many things from here, but from my own point of view, I would always advise, because this is how I do it, you start somewhere from the project view. So there is a project view. If you click on this, this is what you see as a project view, and there is the portal view. So if we go back to the project view, this is what we see. Now, what you see here looks similar to what you would see, for example, if you open any of the Microsoft suits. So you see project, edit, view, insert, align, options, tools, windows, help. There are also quite a lot of symbols here on this part. There are also some things here, devices, plant objects, basically. On the right, you see find and replace, you see tasks, you see libraries, you see add-ins, so many things. Everything is here. You understand? So how do we start? We will go through everything when we start, but how do we start? So usually you start with a new project as usual. So let us say first hardware class. You can always say it should be saved wherever you want it to save, you can save it there. So I'll save this on my desktop. There's a folder there which is training. Select the folder, it will be there. And then I say first PLC train version 20 class. Then you say create. So you're creating a project, just like you create a new document in Microsoft Word or in PowerPoint or in Excel. Basically the same. So it creates a project. Taking quite some time because this is the first time I'm using this as well. I hope it doesn't take so long. So going back to this, I will not use this one directly as an example because I want you to do this one directly by yourself as a take-home assignment. So I will use this as an example, but different system in itself. This is this still creating. Okay. Let me keep this on the side like this so that we can watch it. Okay, so let me explain um, something else then while we wait for that. Let me explain this. Okay, so in many cases, you could have a power supply module beside this PLC. When you do in your hardware configuration as well, you include this power module, whatever you see here. In many other cases, for many systems, I would say 70-80% of the time, you have a 24-volt power supply generator in the control panel, and every other device takes power from this power 24-volt power supply. In this case, you see there are two lines in this drawing, 24 volts. This is 24 volt and 0 volts. I've shown you this before. And then you have the earth. These connections are then made and then linked to the devices that need them. In this drawing that you see here, this is the module itself that generates the 24 volt power supply. There is a 3-pole circuit breaker here, which takes power from line 1, line 2, line 3, and then a 3 phase uh, uh, voltage supply connects to the power supply 24 volts, and this 24 volt power supply is then looped to all systems to that connects 24 volts, that takes 24 volt power supply from this module itself. And this is where the power supply comes from to this Siemens module. So this one connects to this Siemens module, and using the back pane, there is connection and communication with these other devices. I would expect that at some point, there is also power supply connecting from this line to these other devices, because as we've shown earlier, the power supply from the PLC itself cannot power all these devices. So at some point, you need to connect 24 volt to these other guys. Here, there are two cables that are shown here, and this is what is highlighted here. So it's saying that from the MPI, because this device is a 2DP, which is what I showed you using the S7300 PLC I showed in the last training. So from one of the DP ports, there is the connection that is going to the operator panel. So in this case, this is the operator panel, this is the code. The operator panel also serves as a HMI, and this is a communication cable. I think it's also highlighted somewhere. Yes, it's shown here. This is a Profibus connection. So this is a communication cable in this drawing here. And from this DP, there is another connection going somewhere else. But that's not the main point of the training today. But with this, you should be able to understand what you're looking at when you look at a wiring diagram. Let's see if this is complete now. Yes, now this is ready. So when you create a project, you see now we have some folders here. It says on group devices, security settings, cross device, basically standard folders that you would have when you create um, a project. Now, it says add new device because we currently don't have any device yet. We don't have anything. So if you double click on this, it brings this up. You want to add a new device. So usually first you need to know what do you want to add. Is it a controller? Is it an HMI? Is it a PC system? We want to discuss controllers. So when you click on controllers, it tells you the standard controller types that you have in your hardware configuration that are in your library here. Now, when you go back to your wiring diagram, you need to then check, okay, there is a code here. You look at this code, you can input the code directly into here. You can input the code directly, or you can use it to search. So like I said, I won't use that one directly because I want you to use it. So for example, I know that one is an S7 300, but I want to program an S7 1500. So I'll go to S7 1500, I'll go to CPU. So let me show you the one I want to program. So for example, in front of you, you also have the physical PLC, and this is what I want to use. If you can see this, this is the code that I want to use. So I'll look for that specific code in my hardware. So it says it's S7515. This is 515, 2AM02. So I'll look for this. I'll click this drop down, 2AM20, 2AM02, and it's 0AB0. This is what I have in front of me here. So if you see this, 6ES7 S7515 2M02 08B0 6ES75515 2M02 08B0. In your own case, you also need to look. There are quite a lot, so you need to look for the specific one that you have. It tells you what the PLC does. It's the CPU with the display. It has a work memory of 500 kilobyte, 3 MB data, so many things, right? It can do open user communication, S7 communication, Profinet, TCP/IP, OPC UA. It tells you everything it can do. It also tells you currently the firmware is version 2.9. So you can also use version 2.8 if if your PLC itself in, on it shows version 2.8. However, this is also limited to the type of the version of TIA portal that you have. For example, if you use TIA portal version 11, 12, or 13, probably you only have this controller in its version 2.8. So different versions have different features. For example, if I click version 2.8, okay, nothing changes in this case. If I click version, okay, yeah, it just shows version 2.8. If I click version 2.9, only that changes. So in some cases, different versions support different features. So maybe if I choose version 2.0, probably I would not have, probably I would not have OPC UA server. You understand? But in this case, we can use version 2.9 because our software supports it. So what do we want to name it? So I'll say training PLC, training underscore PLC. Then we'll click OK. When you click OK, the system adds the PLC into your hardware configuration. And then you can start to program your PLC itself. It's also taking quite some time because, like I mentioned, this is the first time I'm using this software and it's just adding all the features now. Does anyone have any question up until now? Okay, no questions. Okay, good. So as you can see, okay, now this is a new one, version 20. Good. So it says protection of uh, confidential PLC configuration data, OP certificates are protected. Okay, protection of confidential PLC. Okay, so this is new, right? This is new. So it's saying that now in this version 20, they want to protect your PLC configuration data from the TIA portal project and the PLC. So you need to set up a password. Okay, so we'll set up a password. The password must contain at least 10 characters. Oh, okay. Okay. Mm-hmm. 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 must contain at least one number, must contain at least one lowercase and one uppercase. Okay. Oh, this is a lot. I need to write something down. Okay. One moment, please. A lot of safety now. A lot of safety features. Okay. Okay. So we look good now, right? So it says next. Mode for PG, PC, and HMI communication. So for example, if you intend to program the PG, PC, and the HMI, secure communication, yes. Access level without password, yeah, full access, no protection. Next, overview. Okay, so this is an overview of what we've configured, and then we can say finish. Good. Okay. So basically, we have the PLC in there now, and you can see what I've been showing you, what I've been telling you all this while. Let me zoom this a little. Let me put this on 140. Okay, let's do this. Now, it shows you the rack, the software rack, and you can see the position where it puts the PLC directly on position 1. Why not position 0? Because position 0 can only take power supply. In this case, because we programmed only the CPU, we're in position 1. So there are many things we can do on the CPU itself. If you go into properties, if you click on the CPU itself, CPU, properties, then there are so many things. So many things. What's the name? Training PLC. Who is your author? You can add a comment. So this is rack 0, slot 1, because you can have so many more racks. For example, if you fill up all the slots on this PLC and your programming still requires more input and output, you can add another rack. Then it will be rack 1, slot 1. Uh, what else is important? Let's keep going. Now, this is the article number of the PLC. This is the firmware version which we configured. You can also change firmware version from here. You can also update the module description. You can do so many things that you want. Now, before we go into interface, Profinet interface, let me quickly go into power, correct. System power setup. So you can see now we have set connection to supply voltage line plus. The training PLC is on slot 1, and this is the power. This is the power it currently generates. This is a positive, not negative. 12 watts. Because we have not added any module yet. If we add any module, and because we've already linked this, then this module connects to the PLC, and then we can see the power consumption from here. But staying on the PLC alone itself. So usually there are the PN interfaces. This PLC has 2 PN, right? You can also see that directly here. So like I mentioned to you, the 2PN does not mean 2 physical ports. In this case, you can see it has 3 physical ports, 1, 2, and 3. However, 2 of them are connected together, which means these 2 ports are on the same network range. They are on the same subnet. They are on the same network range. You cannot use an IP that is in different subnets here. However, you can use 2 different subnets in this case for these 2. So for example, if your PC is connected on this position, you can connect your other devices here, maybe um, The HMI can connect to this. Maybe if you want to control a motor, it can connect to this guy using the same network range. And if your idea is to separate the network ranges, for example, you want to use this for what you're controlling locally, the conveyor, the HMI, then maybe you want to connect this to the SCADA. So you can separate them. And that's why you have Profinet interface X1 and Profinet interface X2 here. Now, if you want to see networking better, it's usually better to go to network view. So here we're currently on the device view. You can go to network view. When you go to network view, it shows you how the device is within the network where it exists. It shows you within the network where it exists. So in this case, let us say now you can see it's only showing two, right? Because this PLC has only two networks. It's not showing the port anymore, the physical port. When you look at the device view, you see it as a device. It's showing you as a device. Okay, I have three ports connect. However, in the network view, it's only showing two ports because it only has two connection ports in the network. So this is PN1, Profinet interface 1, and this is Profinet interface 2 in the network. If you click on the Ethernet addresses, then you can add the Ethernet addresses for the different devices. So for example, this PN2 is clicked and you can see the default IP address. If you click on this one, it shows you the second IP address. And here you can see 192.168.0.1. But if you click on this, it is 192.168.1.1. So this is where the subnet differs. This is where it's separates. You understand? Now, if you go to topology view, the topology view is how you connect this with the devices that are with it in its network. How you give priority in terms of connection, communication. This is the topology view. It's not so very important now. You can also read more about it, but we will be using our device view and our network view quite a lot. So if we go back to our device view, what are the things that we want to configure on this guy? So first, again, we go to general. General looks good. We've given it a name, the author, all of those are standard. We go to the Profinet interface. So this is the Profinet interface 1. Let me just make it short. I'll say PN interface 1. That is what I want to name it. Interface 1. And then we can use PN interface 2 for this. So when we go to the PN interface 1, we need to configure it, right? So let me say we want to use 192.168.1.100, 1.100. So you can give it an address between 0 and 254, if I'm correct. It's in the same subnet. Okay, so let me switch it to 3 first. You see, I cannot use 1 here as well. It cannot be on the same subnet because currently Profinet 2 is on 1. It's telling me that I have the same subnet. However, I want to change this to 2. Then everything should work now. So this is 2, fine. And then I can take this one back to 1. 1, 100, and 2, 100. 2, 100. That's good. So we've configured the IP addresses for the two different ports. And then startup, just leave this as standard. You don't need all of this now. Cycle, I'll explain this as well. Communication load, I'll explain this. System and clock memory. Let me enable this. I will explain later. I will explain this later. So I will just enable it now, and then I will explain it later. Semantic memory card, we can leave this. System diagnostics, we can leave it the way it is. PLC alarms, All of this default is fine. Time of the day, yeah, you can set it to wherever you are. So I'll set this to where I am, which is +1, this, yes. Protection and security. I think we already set a password, full access, no protection, OPCUA. This is communication. I'll also enable this, okay? And it already gives it a default address using the addresses which we entered on the PN ports. System power supply, we've already looked at this. Advanced configuration, enable host and name, just leave it like that. Connection resources, it's telling you the amount of resources that can connect to the PLC using these different protocols or communication modes. Overview of addresses, no addresses yet because we don't have input and output addresses. And runtime licenses, it says you don't have a license, so it requires medium,